Welcome back. In this video, we are going to look at these transformations conceptually, and we are going to think about, well, if we are given a description, can we write that function that would give us the same transformation? So for example 1 here, we have the shape of y equals x squared. So this tells us we know the shape of our graph. We know the parent function is this U-shaped or parabolically curved graph. Now we need to apply these transformations. So instead of just being that regular parent, y equals x squared, we're going to shift it left 3 units, up 2 units, and then reflect over the x-axis. So if we think about our standard form, what we know is we're going to have a format which looks like y equals multiplied times a on the outside, and then we'll say cx minus h on the inside, and then plus k on the outside. So a multiplied outside, k added outside, c multiplied inside, h multiplied inside. And of course, this grouping mechanism just lets us know how our parent function would be applied. So in this situation, we would have squared, but they could represent absolute value bars. It could represent simply a square root symbol over all of that. All right, so left 3 units, up 2 units. These are a shift, and shifts come from adding. So one is horizontal and one is vertical. Remember, horizontal would be on the inside and vertical would be on the outside. So this is y equals, I'm going to say x, since I'm moving left 3 units, left would be -3, so minus -3. So there's a minus inside our standard form, and minus -3, that's going to turn into a +3. And I'll go ahead and put my squared, that's coming from my parent function. And then up 2, we would write +2. If we want to think of reflection over the x-axis, across the x-axis, that's going to be a vertical reflection. So that means we're multiplying by a negative. And if it's a vertical reflection, it would not go inside. Inside is horizontal or x, so vertical means we are multiplying by just a -1 on the outside. So if I were to write this function, I would say y equals the negative quantity x plus 3 squared plus 2. And this graph would give me the graph of my original parent, shifted left 3 units, up 2 units, and then reflected over the x-axis. Let's look at a second example. In this example, our parent function is an absolute value graph. So again, we're going to have that same patterning. A, absolute value of c times x minus h plus k. And we have to look at what these numbers are describing. Here we have shifted right 7 units, as well as shrunk vertically by a factor of 4. So a shift means we know it's going to be an addition operation. So this shift is going to represent either h or k. Now, since we are moving right, that is horizontal, so that would be thought of as +7. So if I started to write this, I would say y equals absolute value. I'm going to have x minus the +7 value, right? So minus +7, that's just going to end up being -7, absolute value. So then we have this vertical shrinking by a factor of 4. If we are shrinking or stretching, that would be multiplication. And since we are shrinking, this needs to be fractional. So this would actually be a 1/4 out there. So we would have 1/4 of the absolute value of x minus 7. And that would be our end function here. This would be the function that is given by this description. I do want to note, I typed these notes a long time ago, and I do think looking at this now, this should be shrunk by a factor of 1/4, and you would see it typed like that on your homework. So it would show up as a fraction. You don't have to remember that reciprocal operation there. So that is essentially how we deal with these situations. So we're just kind of taking our rules and working backwards. As always, if you have any questions, please feel free to reach out. Good luck on your homework.